Hello and welcome to the last 90 days to CAT series. In the last part, we've done expressing a number as difference of perfect squares. In today's session, we are talking about number of ways to express a natural number as sum of two perfect squares. A very interesting topic, a topic which is slightly above the first level. Any square, if you divide by 4 and take a remainder, you will get either 1 or 0. So here 1, here you will get 0, again 1, 0, 1, 0, right? So if you will divide this number by 4, you will get either 0 or 1. If you will divide this number by 4, you will get 0, 1. When you divide x square plus y square by 4, your remainder must be either 0 or 1 or 2. Because 0 plus 0 is 0, 0 plus 1 is 1 and 1 plus 1 is 2. So when you divide n by 4, your remainder should never be equal to 3. If your remainder is equal to 3, this means that you are not going to have any solution. Let's take a very simple example. Let's take 65. 65 can be given as 5 into 13. Here, this number is 4k plus 1 and this number is also 4k plus 1. Let's take a number like, let's say, 91. 91 is 7 into 13. This number is of the form 4k plus 3 and this number is of the form 4k plus 1. We've seen the logic why 4k plus 3 is never going to give you a solution. Why? When you divide this number by 4 and take remainder, this number is going to give you a remainder of 3. This number is going to give you a remainder of 1. Overall remainder is 3. When the remainder of this number when divided by 4 is equal to 3, you are not going to get any solution. Let's say you have 4k plus 3 in even power. Then it should not be a problem. For example, in this case, if you see, you have 7 square here. When you have 7 square here, then this becomes 49. Remainder here is 1 and remainder here is 1. In this case, you can get a integer solution, right? Because the remainder here is 1. But whenever you have 4k plus 3 raised to the power odd, you are not going to get any solution. Let's take a few cases to understand it better. For example, the first case, when n is not a perfect square and prime factors in the form 4k plus 1. Let's take the example of 65. 65 can be written as 5 into 13. This prime number is of the form 4k plus 1. This prime number also of the form 4k plus 1. So we don't have a 4k plus 3 here. So nothing to worry about. The number of positive integer solution here will be equal to the number of factors. So what will be the number of factors? That will be 2 into 2, which is equal to 4. Number of positive integral solutions will be 4. How? Let's see. 65 can be written as 1 square plus 8 square. Solution can be 1, 8 or 8, 1. We can also write this as 7 square plus 4 square. 7 square is 49, 4 square is 60. Another solution can be 7, 4 and 4, 7. I am talking about positive integral solutions. So how many positive integral solutions? That is equal to 4. That is also equal to the number of factors. Total integral solution will be number of positive integral solutions into 4. Why? If you've seen the last part, you will understand this. 65 can be written as 1 square plus 8 square. Can also be written as 1 square plus minus 8 square. Can be written as minus 1 square plus 8 square. Can be written as minus 1 square plus minus 8 square. For every case, you will have 4 cases. So hence, 4 into 4 equal to 16. Come to the second case. Here, n is a perfect square and the prime factors are of the form 4k plus 1. So, for example, let's take this case. This case is 65 square, which is also 4225. So, x square plus y square is equal to 65 square, which can be written as 5 square into 13 square. Both these numbers, 5 and 13, are of the form 4k plus 1. So, nothing to worry about. Number of positive integer solution will be number of factors minus 1. What will be the number of factors here? Number of factors here will be 3 into 3, which is 9, minus 1, that is 8. So number of positive integer solutions is equal to 8. We have listed also all the 8 here if you see. Total integral solutions will be 4 into positive integer solution. We've seen the logic already, that is 32. But there will be one more thing. Because it's a perfect square, 65 square, this number x square plus y square can be written as 65 square plus 0 square. You will have one solution 65, 0. You will have another solution 0, 65. You will also have the negative ones minus 65, 0 and 0 comma minus 65. So 32, which is 4 into positive integers solution, which is 8, plus 4 additional for these solutions. So total solution will be 36. Going to the next case. Remember, if we have n which is 4k plus 3 to the power a, 4k plus 3 to the power b, prime numbers in the form 4k plus 3, where these numbers are odd numbers, or even one of them is an odd number, then you are going to have a zero solution. Talking about a mix of 4k1 and 4k3. Okay, let's say that n has prime factors in the form 4k plus 1 and 4k plus 3. Now here you will have two cases. First case is 4k plus 3 having odd power. When you have 4k plus 3 in odd power, you are going to get no integer solution. Second case is when you have 4k plus 3 in even power. Let's take another example. X square plus y square is equal to 5 to the power 3 into 7 to the power 2. Let me take a very simpler one. 5 to the power 1 into 7 to the power. Now this is in 4k plus 1 form and this is in 4k plus 3 form. 4k plus 3 form is in even power. So this is good. We can get a solution from here. What you have to do is just ignore this 4k plus 3 number and calculate the number of factors from here. So what will be the number of factors here? Number of factors here is 2. So therefore number of positive integer solutions in this case is 2. And total integer solution will be 2 into 4, that is equal to 8. When you have a perfect square, when n is a perfect square and the prime factors are in the form 4k plus 3. Let's take a very simple example. N is equal to 7 square. 7 is in 4k plus 3 form. Whenever 4k plus 3 is in odd power, then you don't have a solution. But when 4k plus 3 is in even power, okay, you may have some integer solution. So in this case 7 square, if you just write the numbers 1, 4, 9, 16, 25, 36, 49, in this case you will have no positive integer solution. Positive integer solution will be 0. What will be the total integer solution? Total integer solution will be 4y. You can write this number as 7 square plus 0 square, right? So 7 comma 0 is one solution, 0 comma 7 is another solution, minus 7 comma 0 is one solution, and 0 comma minus 7 is another solution. Your factors will only be of the form 4k plus 1 raised to the power some number or 4k plus 3 raised to the power some number, except for powers of 2. So what will you do for powers of 2? Very, very simply, let's say you have a number in the form a square plus b square 2 to the power odd. For example, when you have 2 to the power odd, let's say you have 2 to the power 1. So in that case, 1 comma 1 is one positive solution. And similarly, your total integer solution will multiply this number by 4. Similarly, you have a square plus b square is 2 to the power even. Let's say the number is 2 to the power 2, which is 4. Now this number cannot be expressed in positive integer solution. The only solution in this case will be 2 square plus 0, 0 plus 2 square. God bless you all. Take care and bye-bye.